charging station will be continued after finish our training and after meetings of Mr. Khaldun. Today we'll continue with our project. Yes, we'll go to assembly. From scratch. Okay. Did you remember yesterday what we did? You do assembly and the new part into assembly and start drawing. Did you understand and understand? Very clear. Okay. You need only to practical. And I see that you haven't time.
That's the concept we need.
Yes, concept is okay. I know that you understand concept, but practically, it's very important. Please, I know that you haven't time, but you should get time. I don't know how, but you should discuss it with your management to get time for this training to be effective. And it is training to be effective, okay? Because I'm sure that you will switch your softwares with this software soon. This is a plan of Mr. Khaldun and Mr. Shao. Need to switch your softwares that you are using now with this one. Okay, so you should working with your hand. Right? You need to discuss this, organize, you need to arrange this topic with them. It's very important. Now you have an assembly environment, blank assembly. As we said yesterday, that insert new part, you will start create parts, but from assembly to get reference, like we did in cabinet of charger station. Okay, we get a reference of other sides to get relation between components. Okay. You can also start from scratch, no problem. If you need to start from scratch a new part and insert it, it's okay. If you need to start from scratch here, also it's okay. That's the same way, haven't the problem. Okay. Now we will start working with a mechanical composition, like your scanner that you did before. Wood scanner called wood scanner, yes? Wood. Okay. First, if you need something like that. Now, if we have if you have something like that, plate, okay, steel plate, and you have start this project, we need to draw it. First, we need to draw the base. This will be the base. Okay? You can draw it here or draw it in a new file. Yesterday, we made this as a new part and the insert components. Today, we will start to make it from scratch a new part into assembly. Just a new part. Select the plan, which will be the base of project of this component, will be the top. Okay. Just automatically, I will open a sketch and go into this part file. Just has been marked in blue. Start working normal. Control 8. Start your rectangle, your base. Okay, with any number, any length, for example, and go to extrude. Select your sketch. I selected the component marked in blue that I'm working in and the sketch. Okay, with 20, for example, millimeter. Again, if you will see this sign, it means that you are in this component, still into part. Okay, just click. Now you are in assembly. Okay, no part marked with blue, so you are in assembly. Good. This is the first component. Automatically, this first component will be fixed. You can't move. Sure. So, we will start the rack. This gear, this flat gear, called in engineering rack. Okay. Start from this library. These racks and gears are standards, so you will not draw. You just specify. Okay, just have specifications. You will not draw. Okay, toolbox. If you will come this menu, open this one. These books called the design library. Design library. You will find many things. Toolbox is a standard library you will see in your software, in your installed software, installed by default. Have all the standards in the world. American standards, Australian standards, with these flags. You see these flags here? Yes, English standard, Canadian standard, German, Japanese. You have also in India. You have standards in India. This is your what is this? This is your flag or no? What's your Pakistan. You are from Pakistan, yeah. They told me that you are from India. Okay. And this European standard, international ISO, International Standardization Organization, also Japanese, also American. BM, SKF, you know SKF, sure. SKF is a biggest company in bearings. Have a special library of bearing, all type of bearing of SKF. Okay, BM also can be considered as a company. BM, the company name, have some products. Okay, and you will have all components in metric and inch, in millimeter or inch. Okay, so now all this company and this a company and this a company. Why you have a companies here? These companies pay to software company Solidworks, pay to them money, okay, to make advertising for them by added its components into software. Because when you're working on a computer, you need to make a design and will get it's very easy. Don't search on internet, automatically you go to SKF and put the bearing and go to the SKF here in UAE or in Egypt or anywhere. You will buy the number of components. Okay, all components are numbered with serial number. It's a real serial number in the market. So go to, for example, DIN. These many standards: bearings, bolt and screw, case, nuts, o-ring, pins, power transmissions, returning rings, structural members, steel structure like these beams, standard steels, washers. We have power transmission. We have two things: gears and chain wheels. The chain wheels like bicycle. Which chain is a bicycle? You know it? Okay? These gears called chain wheels. Okay? I think that you use for something here in your projects. Yeah. Okay? And gears which having contact. These gears. And chain wheels should have a chain. Alright? There's a difference between them. Here you have many types of gears. Helical gear, internal screw gear. You made this before. Mr. Khadoun said to me that this internal gear made before something rotating all in one other side. Okay, and this is a rack spar rectangular gear. This is a flat one. We will drag it. Click on your mouse, left click, and still drag. Okay. Wait, because we'll open a menu here. It's very important. Hang it and it will come. Don't worry. Just hang it. Okay. Not responding. See, it's recovering. Also the same way if electrical has been done. Recovered. Go to toolbox. Power transmission, gears. This rack. Fence. upload. Okay. Crazy softwares. No. From any another standard, not important din. This on transmission gears. This track units. Yes. Alright. Now we'll open something like that. This is a configuration. Each component will be inserted from toolbox. Will have its configuration. You will not draw this rack, but you will configure only this rack. Okay. Let's show these configurations. It's very important. Face width. What does it mean? This width, this dimension. Face width 10. Just right. Yes. 5. Don't press enter. Go to another, select another toolbar box, text box. Okay, this is a face width. Would be 50, for example. Pitch height. Pitch height. Okay, and length. Length. Very clear. If 100. It's the length. Total length. Okay. Pitch height. Pitch height, what does it mean? If we change it to 100, we control the height of rack. Okay. Okay. 30. Okay. And now we need to control the size of teeth. Okay. Let's review. Face width. This one. Pitch height. This one. Length. This one. Okay. Engineering rule, not in software. To identify any gear can be identified by something called module. Also, if you go to buy a gear from the market, the first question you will get from seller, what's the module and number of pieces? Module and the number of pieces. Okay. Module is a standard worldwide. These numbers are standard worldwide. So you select the module you can use, suitable size for you. There are something considerations in engineering, but would be difficult to explain it for you, okay? Because you are working with advertising, having something not precision like aerospace or automotives or high mechanical motions, something like that, okay? Module 4 and length will be how length of 2 meters, 3 meters, 4 meters.
Five.
5 meters, okay. So length will be 5,000 millimeter to equal 5 meters. Wait on him because it generates a million of pieces around this 5 meters. Okay. Now we can change module to be larger. Yes. This module is 5. Okay.
What is that module? I thought the people are
Distance of what?
the module.
No, this module is a general equation. Let's see. The module is the piece of any view has a shape. Okay, this is design. Okay, there are some pieces like that, straight, and some pieces are curved. Okay. Can you see or translate this from here? You can come to see because it's not software. It's a theoretical. Okay. I will delete this. Okay. Three pieces. Alright? These teeth have outer diameter, okay, and they have internal diameter at the tips of these, and have another diameter, is a virtual diameter here. What's this virtual diameter? This virtual diameter is a contact between the teeth and the other. Okay? When you will get another gear like that, here. Okay? Start working together. These are a contact point between them. And give the contact in a contact point, not contact line. With your normal eye, you will think that the here all teeth contact with the all teeth or another teeth. No. The real contact in one point, in this point, in this point. Okay? This contact will generate motion. Okay? If you rotate this like that, and this teeth will contact this teeth, sure, when we need to remove or rotate, this also will be rotated. Okay? Clear? Alright. The main contact here. So this is a virtual diameter. What's a module? Module is a relation between this diameter and this diameter and the number of teeth. general equation, worldwide equation. Okay? What's this equation? Module M, sorry, module M equal what? Equal this diameter, this visual diameter, called D1 for example, divided on thesis. Divided on thesis. Number of thesis. Number of thesis. Okay? This general equation. So, in standards, gears has been divided into a table from two module number 2, module number 3, module number 4, module number 5, standards. Okay? Has been generated from this rule. Alright? So, you can control your type of teeth if this teeth is soft teeth that have small height, called soft teeth, okay, have a small height, 2 millimeters for example, just soft. Just see something like that, like this, like cars. If you have a car and you can see the connection between couplings, you will see some drum, a shaft, small shaft with 20 millimeters, have some called something like that. Small. You need to see with magnifier. Okay, these soft teeth have small height and small width. Okay, so have also small module. The module number will be small. If your module number increase, the teeth will be hard, rough teeth. What do I mean rough teeth? You can see, a big teeth you can see. Okay, you can see, have size, height, the big teeth. Okay, what's the application? But when you use soft and when you use hard. Hard teeth, if you have a large assembly, like the cars, like this project that you made before, and you have 5 millimeters, okay, this means that you have a 5 millimeters of racking, like this one, okay, and there are a gear with them. We're working many times, 1 month, 2 months, 3 months, okay, go and return, go and return, go and return, go and return, okay. So in this case, you will use a hard teeth or a rough teeth, okay. Why rough teeth? Because we need to avoid any friction, avoid any wear, okay, because there are steel with steel, okay, are interference between them. Any two materials in the world, when you make frictions, one of them will be wear, have a wear, sure, okay, understand very clear what I mean, okay. So now to avoid a big wear and get more lifetime for your project running, okay, so I need to make these thesis very hard, okay, get high thesis, okay, with a ratio of size. It's by your eye, by your mind, okay, according to your ratio you need, okay, and material would be good steel. Right? Clear or no? This answer covered your question or no? This question has been covered, or have something not? If you have an answer query, tell me. It's okay? Now, if you make this module 5, this means that when you will select the another gear, spar gear called spar gear, also you should select module 5. So nothing in the world can't connect, can't install two gears with different modules. So if this gear a module 5, the another gear will be also a module 5. You can change number of pieces, okay, to get the ratio of movement, alright, but module should be fixed, should be constant. Okay, now also module will be 5. And number of pieces you can change. Number of pieces is 1, 2, 3, 4, 5. Can change according to your needs. Alright. And also you can select face width 30 and shaft diameter, the internal hole, can select it, size of internal hole, keyway. You see this? Okay, this why. You know why? You know this why? Lock. Yeah. Why? If this gear like that. If you have a cylinder like that, okay, and a shaft, this shaft will be installed into cylinder. Okay. Now, if I will fit it with it, okay, so and rotate this shaft and have a load here, if you fix this cylinder and shaft will build it, nothing wrong. You should make two solutions. If make with welding, weld this shaft in this gear, okay, by welding the edge to fix them together, or make this key. Okay, this key, you just make something like that, just in groove, just a groove. Okay, and this groove, you will make another groove in this one. See, two grooves. To see finally from this view, this is a shaft and this is a leader. Okay, so these grooves will be faced each other, okay?
You will put the steel inside of the one?
Yeah. After that, you will give the key. You find here, if you remember, that we found that this name, toolbox, tick 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 tick, future ring, bolts, snoring, bearing, bolts, orange nuts, in ISO, pin, key. This key. These standard keys in the world, standard worldwide. What's this key? This groove has a standard size, and this groove has the same standard size. So you will give this key just a block, just a steel block. Okay? You will get this steel block here. This steel block will connect each together. without welding. Okay? If you need to uninstall it, normal. Get any pin, any small pin, and with the hammer.
But sir, sometimes I saw something like it's already in the cylinder already on the top already.
What do you mean?
Something like that. The gear is already like this, but this one's like this.
Ah, yes, if from this, but not standard. Manufactured by manufacturers, okay?
But
By man, yes. But if standards worldwide, you should have this one. Because something for logic. When they made this one piece in engineering, not correct. But maybe working in your field because, as I said before, you're working in advertising, not accurate, like aerospace or automotives or high machines, okay? But this engineering wise, not good. Why? May have an overload. May have an overload. Okay? So I have this axe. We have a thing, it is something okay. Thank you. Okay. If you have this one piece, and this here, and this here, alright? When this shaft will rotate in this direction, sure, this cylinder also will rotate at the same, because they have connected, right? Okay. When have a resistance from this, a resistance, if you come with your hand and start to push, try to push, okay? Try to stop it with your hand, try to stop it with anything, with a friction, you see if it's a car moving, okay? Have a load, my weight and your weight and your weight are still in the car, have a load, okay? This load will act another force, will act a force in the opposite direction, okay? Clear till now? Okay. This force called resistance R, and this called F force, and this called F force, okay? This resistance will make back effect on this zone. If the zone not suitable in size and can support this resistance, will be broken. Because it's a very weak point. Okay? A very weak point. So, but it will be broken, we have a problem. All the shaft has been in the cycle bin, go away, waste. But if you have a groove and you have a key, the key only will broken. Just key. Just key size like that. With fence, not dirhams. Goes to fence. Okay? You will get it out and make another one, and your shaft is okay, and your gear is okay. Okay? This is a mechanical concept in this way. Alright? Now, we have the rack and gear with the same module and sizes, it's okay. Now, we need to put their assembly in relation together. So, first, you should decide which one of them you need to move and which one you need to fix. So, I can move the gear, rotate the gear, okay, and the steel gear will be rotated and move at the same time, okay, like that. And may fix the gear, the rack will be removed, moved, okay. According your decision, you will start working. I think that if you have this big lens, okay, it's very easy to move this gear, not this one.
Because you move that one 5 meters. If you move like 500.
Yeah, this means 500, 5 meters. You need 5 meters before and 5 meters after, okay? Alright, so this is fixed already, but maybe fix it not in the position that we need. So we will right click float. Do you remember this float? Okay, to make it free, and we will reassemble it in the position that we need. Top, with the top, and in advanced mate symmetric. What is symmetric? Symmetric mean in the first choice you will select the plan. You need this part in symmetric, okay, and the two faces between this plan, this face and this face. Now in symmetric, this face and this face in the middle of this plan in advanced mates. Also you can do symmetric for right and take the not point face and the other face. Okay, so has been fixed already. Coincident, symmetric, symmetric. It's okay. Move? No, you can't move. It's okay. We need to take this gear and start assembly this gear mechanically. First, we should align this gear, align this direction. This gear will be aligned to rack. Okay. Also, we can use advanced mate symmetric. Okay. And make it near with your hand before working, like that. With your hand free, normal, no problem. And now you have made mechanical made gears or rack pinion. This called rack. This called rack. Gears you will use if we have two rotated gears. Okay. Rack if you have a linear gear, that's called rack. Okay, and rotated gear. So let's concentrate together because we have a big critical point. When you assembly these two gears, you have a condition. What's the condition? I want to rotate each round, okay, should have special distance. Alright? So we'll give you this one. If I will mark here, Each round, okay, should have special distance has been percoursed. Okay, this is a relation between diameter and number of rotations. Okay, so if you have a rope, you know a rope. Okay, have a slender and rope. If you have a cylinder, this cylinder with a specific diameter, have a diameter, okay, and this straight. This cylinder, when we rotate, already will move. Okay, so when we rotate from this point, this will start point S. But when we rotate after one round, this start point will get in the same place, but the body will not be in the same place. Okay, will be here, for example, after one round. Okay, this distance, how you can get this distance equal the perimeter of total length of this cylinder. Total length of the cylinder. Okay, you have a paper, please. Two papers. Okay, S3. But this of the thing, yeah. You need or no? I don't know. If not needed, we can do. This is an engineering concept you should have. Okay, because any software can be applied with the problem. Exactly. You have a solitaire tape. Sorry, disturb you. I will start this one. Let's come in now. Now I will put this line here and this top part. Okay, will count. One round, yes. This distance equals that. The same, yes?
Yes.
Be the same? Why? Is the total length of which is cylinder, which is circle. Okay, total length. How can get 2 by r? Is a rule of total length. It's very important for you. What is 2 by r? 2, number 2. Okay, r, the radius. If you have diameter 10, radius will be 5. Okay? What is a constant value in engineering called pi, called p. Okay? This is called or pi, called in American and British. Okay? This value 3 point constant value, okay, or 22%. The same if you make calculator. Okay, so here 340 by 5 by 2. This is a rule to get the total length of a circle. Okay, and as we made practically, really one round equal the total length of this body. Alright? Clear?
Did you understand why r was the pi? Do you know from where the 3.1416 come?
Where from this now?
Yes.
2 divided by 5.
2 divided by 5? No. Why?
This constant.
Why the circumference? How we calculate the circumference of the circle? Yeah, diameter times what?
Diameter.
If we have the diameter, we don't have the radius.
Right times diameter.
If we don't have the diameter, how we get the
Circumference. You have a circumference of the circle. Yes.
sir.
This is the circle. Yes.
Yes, sir.
The diameter is 6 cm.
Yes, sir.
You can calculate diameter times pi. You will get the circumference. If you have the radius,
Yes, sir.
radius times no diameter times pi, you get the circumference. If you have the radius, how you will get the circumference? What is a radius?
It is total length of the circle.
It's not. What is the radius? Diameter is the total length of the circle. Radius, what is? It's half of the diameter. Yes?
Yes,
From core to edge. This is half. So the half you need to multiply it by 2 times the pi. Diameter times pi. The pi is, what is the pi? Pi is engineering calculation, how you get the length from here to here. How to get here to here, how to get this result is dividing 22 divided by 7. You will get the 3.1416, blah blah blah, infinity numbers.
yes, sir.
So the pi is how to get this circumference.
Yes.
But you need to know if you have a diameter, how to multiply a diameter to get the circumference. And you need to know how to multiply a diameter to get a circumference. So, diameter, what is the diameter?
Diameter total circle.
you need to study what the meaning of diameter and the radius. What is your studies? Diameter and radius. This is the simple thing you should know it. في واحد
ولا طبعا.
You have a circle. If you come and you cut the circle from this side to this side, this is what you call a diameter of the circle. Once you have center point until the edge, this is where you call it radius. So if you are calculating the circumference of a circle, you need to know the pi, how the pi is the pi of engineering, how they get a plan after they study and after they divide the circle into many stuff, they come up with a rule. This rule called a pi. And this pi is because of an equation 22 divided by 7. They come up, the pi is equal to 3.1416 point blah blah blah. If you divide, you will get this number exactly. Okay? So to get the size of this, if you get the radius and you multiply it directly with the pi, you will get half of the circle. If the radius, you multiply it directly with pi, you will get half of the circumference. You don't get the full circumference of a circle. Okay? So r times 2 multiply it by pi, then you will get the full circumference. Okay? Once you have the dia, okay, multiply it directly with pi, you will get the circumference of a circle. You understand what the difference between diameter and radius?
Yes.
Okay?
Okay. So now is some sketch I will write. Now I need to make a mechanical assembly between them. Mechanical assembly. Okay, we can give it another side because we have this sketch, it's very important. First, make it with your hand before you start working. So let's start. Now, if we need to connect this drag and gear together, you have to do something as the first. This rack is the first one. We'll go and show sketch called tool cut seam. Okay, tool cut sketch seam. It's very important because you will open and show the teeth conditions. Okay, just show. Right click, show. Right click, hide. Right click, show. And go to this also. Tooth cut and show. Find this and this one that we explained at the first lecture. Yeah. Can you see something that this sketch tangent automatically with this sketch? Can you notify that? See, when I tangent them, this is the right way of connection. not like that or not like that. This point, this called pressure angle, is the best zone of contact between two gears. Okay, the correct zone of contact between two gears. Like, do you remember what we said before? Okay, when said what's the teeth and what's the critical point of teeth. Okay, so now you can start your assembly with these guides, this circle and this line. Meet. Not standard, not advanced mechanically. Rack pinion, not gear. Rack pinion, because we have a linear rack, a linear gear. Okay. This rack pinion, this can be the rack and this circle can be the pinion. Okay, has been tangent already together. This is the first you select. Okay, this is the pitch that will make this practice. Okay, he asks you pitch diameter or rack travel revolution. We will use this one. Why? This is the same. Rack travel revolution. Okay. Each rounding gear, how many millimeters will be traveled? As we made in this. Okay? Clear? Or not? Okay? Okay? Based on what? Based on total length of circle. Okay, we will make this number. It's okay.
Can the software calculate
Yes, sure. We already calculated.
calculate the travel speed?
Yeah. Okay. But we need to fix only you need to fix normally this gear to be not out and down. Okay. What you can fix? How? Very simple. Just mate, normal mate, tangent. This with this. Thank you. Make it tangent. Can tangent them first. Okay, if it's can tangent, no problem. Doesn't need to tangent because we used this line before. Okay, can tangent it like that. Alright, and can take sketch. Normal sketch here assembly and make a line here like a center line just for construction. Click on the line. If you need to convert it, you haven't to delete, no problem. Not need to delete and redraw again. You can just click on the line, left click from this option, horizontal and vertical like that. First horizontal, and for construction will be converted from to. Okay, shortcut, like a shortcut, and you will get it here with this one tangent, and remove again this tangent to get this line free. Okay, just I need to position and have a sketch. You can now go to assembly, tangent, this line, sorry, with this one, or with this one. Okay, with the gear itself. See? High accurate. Okay, it automatically when you make this rack, he will automatically get the total length automatic. When you select this circle, automatically get the total length calculated. Okay, not need to calculate manually. I just explain to you to know the concept. What's the concept between hide the sketch, just hide, don't delete, and you can also hide the other sketches here that will make a show. Toolcut, right click, hide, don't need. Okay, also this can be hide.
What is the distance of travel?
دي واحدة 5 meters total طول.
How many minutes?
ايه؟
How many minutes?
It can be calculated with calculator, no problem. According to number of gears, number of rounds in motor. If you have a number of rounds in motor, you can. Now, I would say to assembly or charging. No, charging. No, this is.
There is any calculation that do it automatically?
Yes, we have a motion analysis, but it's very complicated. في motion analysis هنا بيحسب ويديك شرطات ويديك عزوم مواتير ويديك القصة اللي دخلنا فيها. الناس دول ما ينسوا اسمها مصر.
I'm
Let's say-
looking here
let's say-
something in this one. You have to travel 5 meters.
Okay. In how much minutes you need?
Like 1 minute, 5 meters.
Okay. It's manual equation. Now, this equation, okay? No computers. We will save us, but you have inputs. What's the input? Length 5,000 millimeter. 5 meter. Okay? You should unique the units. Right? And time
60 seconds.
how many minutes?
60 seconds.
60 seconds. Okay? And gear travel by round come from here back travel by one round by one revolution.
Now, let's flip it. You have 3 components usually to get a motion rotation or whatever it
This
is.
is very important.
Yeah.
This rotation, this is very important number to you. If this gear will be changed with a big
Yes,
size.
Mahu, you don't have the gear. What you have is three components. You know the length of the distance of travel.
Okay?
So, which is the 5,000 millimeter. Then you have the time of travel. How many minutes you need to travel from point 0 to point 500. And then you have the third one, which is the power generation, which is the engine itself, or it is the motor itself. You have a motor already, yes, with an 11 RPM.
Motor 11.
RPM.
Okay.
Rotation per minute. Do you know about the RPM? How many rotation it rotates per minute?
Okay.
Now you need to make it happen. What is the steps you will do it first? These, you don't have gears here. You need to fabricate the gears to get the distance you need to travel in 60 seconds with a motor of 11 RPM. From there, this is the information that you will have, and this is always the situation that you will face. You are not a motor manufacturer. You have standard motors in our store, and all our motors are 11 RPM, okay, with a different torque. The torque is another thing, which is weight. You can put the weight, let's say 100 kilogram. Okay, but I don't base the weight. You can distribute the weight on you can remove the load, the weight load, transfer with another type of application. There is many ways how to remove the weight from the gear, but there still will be a torque required from the gear to move or to pull. It's like you are pulling a car. Yes, the weight of the car is not on the engine. The weight of the car is on the floor, but the engine is carrying or pulling this weight. You are pulling the weight. You are not putting the weight on the gear, and the gear need to produce the motion. Okay, so these are the three components that you have it here. From there, start. We have this before, yes or not? You were here when we do the Nissan scanner, or you